In example 3, we have a limit as x approaches 0 of this particular function. This function is undefined when x is exactly equal to 0, but we really don't care about that for a limit. Let's get our graphing calculator out and type this into y sub 1 and see if we can figure out what this limit is equal to. I'll need parentheses in the numerator because I have more than one term. So I've got 2, and then I'll do second natural log will get me the e to the x. Just type the x in. Make sure to cursor out of that exponent position, and then you'll type your minus 1. Then we need x in the denominator. Let's take a look at the graph by hitting zoom 6, which is not always the best viewing window, but it is often a good idea to start here. It looks like the limit as x approaches 0 from the left is negative infinity, and from the right it's infinity if we look at the graph. And we can see that here on the left and then the right. Let's see what's going on in terms of the table, and we'll hit second table set first. I'm going to start my table at 0. My delta table should be 0.001. Then I'll hit second graph, which is the table, and we can see here that actually as we approach from the left, I've got negative 248, negative 331, negative 498, negative 998. So it seems like those numbers are just getting more and more negative as we approach 0 from the left. From the right, the opposite happens. We've got 252, 335, 502, 1002. Those numbers are just getting bigger and bigger and bigger. So I think for this one, we're going to say that this limit does not exist. And the reason is because the limit from the left, which is negative infinity, is not the same as the limit from the right, which is positive infinity.